Alright guys, you know a lot about the derivatives, and I am wondering if you were wondering what would happen if we needed to find a derivative of a function other than the ones we were working with. So we kind of did the rational functions, the polynomial functions, and simple functions like this. Now what would happen if I wanted to find the derivative of a trigonometric functions? Now you should have even more questions. Well, what about logarithmic functions? What about exponential functions? Well, that's next. Today we are going to just concentrate on the trigonometric functions. So our goal for the first exercise is going to be to find the derivative of the sine function. So if f of x is equal to sine of x, we will want to find a derivative. But if I just give you something like this and tell you to find a derivative, well, I don't know what to do. So what we are going to do is we are going to use the limited definition of the derivative. So this is what we had used way in the past where we started the introduction to the derivative. It was this long way. I will do this with you so you can get an idea. But before that, I want to remind everyone that when we were talking about the limits, limit of the expression that is sine of x over x as x goes towards 0 is defined as 1. And before we solve the example that I had asked for, I want us to figure out what is the limit as x approaches 0 of the expression that looks like this. So notice that this is going to give you a 0 over, well, cosine of 0 is 1, so 0 over 0. So this is problematic and we need to do something about this. So what we can try, now everybody remembers this, right? Limit as x approaches 0. We can try to multiply by the conjugate and again hope for the best. So cosine of x plus 1, and now we are going to divide it by x times cosine of x plus 1. And let's see what happens. Let's see if I left myself enough room. So we need to remember that when we are looking for limit, we need the limit notation. So as x approaches 0, this is going to give me cosine squared minus 1. Over, I'm going to leave this alone for now, and then we will see where we are going with this expression. So I have cosine of x plus 1. This is definitely still problematic because this is division by x and x is approaching 0, so that would still give me an expression that is 0 over 0. However, if we now go back to our favorite part of mathematics, or one of the favorite part of mathematics, which is trigonometry, we would remember that cosine squared minus 1 using the Pythagorean identity will be equivalent to negative sine squared of x. You think why? Well, sine squared of x plus cosine squared of x is equal to 1. So if I want the cosine minus 1, that is going to give you negative sine squared. And we are going to divide it by, and I'm just debating if I want to multiply or not. I am not going to multiply, so it's going to give me x cosine of x plus 1. And now I'm thinking what to do next. Well, what I will do next is I am going to look if I can somehow split it, because again this is still a problematic expression. So because this is sine squared, what I can do is I can write this as sine times sine. So if I do that, that is going to give me limit as x approaches 0, and I would have sine of x, I have a negative somewhere there, times sine of x, and it is divided by x, and then I have the cosine of x plus 1. So if we think about this expression, and if we think about what I gave you at the beginning, we know that if we have sine of x over x, so if I just take this part, I know that this is approaching 1. And now if we plug in 0 here, this would give me cosine of 0 is 1, and then 1 plus 1 is 2. And this sine of 0 approaches 0, so this is 0. This goes to 2, but it doesn't matter because I have 0 divided by 2 times 1, so the entire expression is going to still approach 0. Notice this was not problematic because in the denominator we had a number, so that's fine. And it's okay to have 0 in the numerator because that is okay to divide like that. So we did find this, we will use it in a second. And now we are finally going back to our example to find the derivative of the sine of x. And I am, again, this is what I had assigned at the beginning, and on the way to that example I did a whole bunch of other things. I want to now finally find the derivative of sine of x using the limited definition of the derivative. So before I start, I want everybody to remember the definition of sine of the sum. This is one of those formulas that you had on your formula paper. I am giving this to you, so remember this has nothing to do with distributive property. You have to find the sine of alpha, multiply it by cosine of beta, plus cosine of alpha times sine of beta. At some point of our lives, we did prove that this is a true statement. So now, going back to our limit definition, we will take limit as h approaches 0. We will have sine, and now remember this is where I plug in x plus h in place of the first x. So I am going to have x plus h minus just sine of x, and I am going to divide it by h. Again, this is one of the first lessons from this unit. So I am using the definition, and if you plug in 0, again, this is going to be problematic because you would be dividing by 0. Now, this is why I wrote this formula, because now you can apply this formula for this first term. Limit as h approaches 0. Let's see, we are going to have sine of the first angle, cosine of the second angle, plus cosine of the first angle, sine of the second angle. Do not let me mess up. And then I am going to subtract sine of x, and I am dividing this by my h. All right, remember when we were doing this before, I always say, well, let's do something and let's hope for the best. So what I mean by hoping for the best is we need to think about, well, can we cancel anything out? Can we factor something? What can we do with this expression? So if we take and put this sign with this expression and take sine out, again, those proofs are sometimes hard to think of what you would have to do. And with the mathematics, you need to be patient, or you need to have someone to show you how to do it. So in this case, well, I will show you. So we will take the sine. I will just rewrite this in a different order. So you will see in a second why I'm doing this. Sine of x cosine of h minus sine of x over h, and I am just moving the cosine of x. I'm just changing the place, sine of h. All right, so now what I am going to do is I am going to factor out sine of x from those two terms. So I have limit as h approaches 0, sine of x, and I have cosine of h minus 1 left. And this is over h. And I know where I am going with this, and I know that I want to split this. So my next expression is going to be the term with the cosine, and notice, because I'm going to split this, I am allowed to write this as a sum of two limits, h approaching 0, cosine of x sine of h divided by h. I'll move my paper. Again, this is still problematic because h is approaching 0, h is approaching 0, so this is really not giving me much. However, let's see what we can do next. I could, this is multiplication here, so I know that this expression, so if we do sine of 0, that's 0, but that's fine because it is in the numerator. But now, and I do need to move my paper a little bit. When we started this lesson, we showed that limit as x approaches 0 of cosine of an angle minus 1 over the angle is equivalent to 0. Okay, we showed this, so this was our proof. So what I want you to see from this expression, this is approaching 0, and that's fine, this sign, right, because that's our value. And this as the entire expression, so not dividing by 0, we are not doing anything illegal. This is also going to approach 0. So this entire limit is going to go towards 0. All right, let's see what the other part is, because at this moment, this is basically cancel out. This is canceling out. So basically what we are finding is limit as h goes towards 0 of cosine of x sine of h over h. Well, take a look at this one. We have sine of h over sine of h. And this was, again, I am moving my paper on the top. You guys will be able to take a look at your notes. That limit is equivalent to 1, right? And we've already showed this. Here we are using h's, but as long as the letter is the same and this is h approaching 0, we know that this expression is 1. And we know that cosine of 0 is also 1. So my final answer is going to be, well, this is, I'm sorry, I shouldn't say 1 because I cannot plug in the 0 for cosine. This is x. So this is just going to be cosine of x times 1, which is equivalent to cosine of x. So notice what we just showed. We showed that the derivative, so I will write this way. If my f of x was equivalent to sine of x, if my f of x was equal to sine of x, then the derivative of f of x is equivalent to cosine of x. Beautiful, huh? So derivative of the sine function is equivalent to cosine function. And we just proved this. All right, let's make this a little bit more interesting. You should question, you should wonder, you should think about this. All right, so we do know what is the derivative of the sine function. Derivative of the sine function is a cosine function. What are the derivatives of the remaining 5 trigonometric functions? Here are the definitions, and you could prove each one of them the way we proved the previous example, and I will assign you to make a proof or do the proof. But the derivative of cosine is defined as negative sine. The derivative of a tangent is defined as secant squared. Cosecant, derivative of cosecant is negative cosecant cotangent. Derivative of secant is secant times tangent. And derivative of cotangent is negative cosecant squared. And I hope I copied this without making any mistakes. All right, having said that, a few more examples. I want us to prove, notice I am not going to use limits anymore. I will ask you to prove cosine using limits as a homework assignment, but we are going to prove that the derivative of the tangent function is in fact equivalent to secant squared. All right, So let's see. If my f of x is equal to tangent, well, I don't necessarily like to work with tangent. I am going to switch this in terms of sines and cosines. Remember your formula paper on the top right corner. It says that a tangent of x is equivalent to sine over cosine. So now if I want to find the derivative of this is the derivative of the division, quotient. So what I am going to do is I am going to find the derivative of this function, which we just proved that this is equivalent to cosine. I'm going to multiply it by the whatever the other function is, which is a cosine. Again, you can write this out. Then you will have minus sine, minus, and we will multiply it by sine. And we do know from the formula paper that the derivative of a cosine is negative sine of x. You will prove that this is in fact a true statement as your homework assignment. And we are going to divide it by cosine of x squared. All right, let's see what we can do with this. Cosine of x times cosine of x gives me cosine squared of x plus, because I have two negative signs, sine squared of x. And I'm going to divide it by cosine squared of x. It doesn't matter, those are equivalent notations. And now everybody remembers that cosine squared plus sine squared is 1 divided by cosine squared of x. And that is equivalent to secant squared of x. You just made a beautiful proof. And we are going to make one more. And after we do one more, I will give you a little bit work to do. So we want to prove that the derivative of the secant of x is actually equivalent to what I did give you on a piece of paper with the formulas. So, well, let's see. If I want to write a nice notation, I will start that my f of x is secant of x. And again, this is not necessarily my favorite one. I'm going to switch it. Secant goes as a reciprocal function for cosine. And let's see, if I want to find the derivative of that, what I am going to have is I am going to have the derivative of 1, that's just 0, times cosine of x, minus this is not changing 1, and then derivative of cosine, by the definition it is negative sine of x, and I am going to divide it by cosine squared of x. Well, this is getting cancelled out. Negative times negative is positive sine of x. Divided by cosine squared, I am going to write this as cosine times cosine. Why? Because now I get this and I get this. Sine over cosine is tangent. 1 over cosine is secant. And I'm done. And this is what we did say. The formula says this backwards, but it really doesn't matter. Well, that's it. So think about this for a second. Keep this paper in front of you for the proofs. So those are the formulas. This is something that, well, Mr. Hendrickson will have you memorize. But for what we are doing, just keep this in front of you. All right? A few examples for practice, just like the ones we did right now. All right, make sure you have fun with this and see me if you need any help.